This video deals with the gradient of a straight line. What is a gradient? Well, a gradient has to do with the slope of a line. How tilted is a line? So a line like this is said to have a higher slope than a line like this. Imagine you're climbing up this line and you're climbing up this line. It's harder to climb this line than to climb this line. This line is said to be steeper than this line. This line is said to have, so I'll call this line 1. Line 1 is said to have a larger gradient than line 2. The gradient has to do with the steepness of a line. And a gradient is a value that can be measured. And we'll go into that later. But I mean, let's even look at the idea of a case where you have a hill. As a hill, imagine you have a man here climbing this hill. And imagine you have this hill. You have a man here also climbing the hill. Now this guy's just going to walk over with no problems. But this hill is much harder to climb. Not because it's higher, because it's steeper. Because this is steeper. I mean, if you look at this, it's harder to climb along this line than along this line. A line like this is harder to climb than a line like this. Imagine you're standing here walking up. Imagine you're standing here walking up. So that's the idea of a gradient, but it will become clearer shortly. But another thing I need you to understand is the fact that a line that increases from left to right, a line like this or a line like this, is said to have a positive slope. So let me show you what I mean by this statement: increases from left to right. Increases in height, that's what I mean. So let this dotted line be like a horizontal ground, and let this line be some kind of, well, just take this as a line. You can see that as we move from left to right, the height of the points on this line from the ground, the dotted line, are increasing. Same thing here. I mean, look at this arrow. Look what happens. The arrows are getting larger because the height of the line is increasing from this base. Lines like this are said to have a positive slope. Lines increasing in height from the imaginary horizontal line from right to left, like this line or this line, are said to have negative slopes. As you can see, the height of the line increases relative to the dotted line as we go from left to right. Same thing here. Height of the line increases as we go from right to left. So lines that increase as we go from left to right are said to have positive slopes. They have positive gradients. Lines that increase from right to left, like this line, are said to have negative gradients. Now gradients, as you find, can be characterized by a number, like a numerical value like 2, like 3. But what I'm trying to say is some lines have positive gradient, some lines have negative gradient. So this line, for instance, could have a gradient of -2. The key thing I'm trying to point out here is this line has a gradient that has a negative number of value. Lines like this will have gradients that have positive numerical value. So this line can have a gradient of +2, +3, whatever. So the key thing here is to note lines that increase from left to right have positive gradients, positive slopes, and lines that increase from right to left have positive gradients, which is the same thing as having a positive slope. So slope, the words slope and gradient are used interchangeably. Now we're going to move on to determining the gradient of a given line. We're going to determine the numerical value for the gradient of a line. And I'm going to use a method known as the triangle method. So here's a line. Now, this line gradient can be determined by forming a triangle as follows. Draw a vertical line down from the highest point. Just draw it down. So a vertical line. And draw a horizontal line to meet the vertical line from the lowest point. So we just formed a right angle triangle. Now, I'm going to call the length of, this line, so from here, this top point to here, this line. So in reality, imagine you had this line drawn on paper and you actually had a vertical line downwards. The length of this line has a value. So let me call that value, I'm going to call it y. Now this horizontal line has a value. If you measured it, you'll have a numerical value. If you measured with a ruler, it'll have some numerical value. It could be like 5 centimeters, but I'm just going to call that x. And the key thing here is when you have a line, in order to determine its gradient, you form a triangle as follows, and the gradient, I'm going to call the gradient m. Okay, that's getting a bit confusing. I'm going to call the gradient is given by y divided by x. That's all. It's the length of this vertical line divided by the length of this horizontal line. That's all. However, you also need to take note of the fact that a line like this has a positive gradient. Therefore, the gradient must be positive. So I'm just going to put a plus sign. And you see why now. Because if I had this line, to determine this gradient, I'll draw a vertical line. Downwards using a ruler. And I'll draw a horizontal line from the other end to meet the vertical line. I'll measure the height of this vertical line up onto where it meets the horizontal line, call that y. I'll now measure the length of the horizontal line, call that x. The gradient of this line is also y over x. So the vertical height over the length of the horizontal line, basically. Basically the height of this vertical line divided by the length of this horizontal line. But because this line increases in height from right to left, it's a line with a negative slope. So I just introduce a minus sign. So lines like this, will have positive slopes. Like lines like this, will have negative slopes. So we're going to look at some examples. So imagine you're given a line like this. In fact, imagine given this line and you're also given that. Imagine the dotted lines have been drawn out for you. And you're given the height. You're given that this height is 10 and the length of this horizontal line here is 5. This is a line. I'm going to call this line AB. So this is point A on that line and this is point B on the line. So this is line AB. And let me use a different color. Line AB. The gradient of line AB is simply the length of this vertical line, 10, divided by the length of this horizontal line, 5. And it's plus 10 over 5 because this line increases from left to right. So this line has a positive slope. Remember, any lines like this, which increase in height from left to right, have positive slopes. So simply, the gradient of this line is plus 10 over 5 is 2. Here's another example. Imagine you have a line. So here's a line, and imagine the vertical line downwards has been drawn for you, and the horizontal line to meet the vertical line has been shown as well. That's not clear enough. Just going to do this in black. And you're also given that the height of this vertical line is 20, and the length of this horizontal bit is 2. What's the gradient of line AB? The gradient of line AB is simply the height of the vertical line you get when you draw a line downward from the highest point to meet this horizontal line, divided by the length of the horizontal line that extends from the lowest point to meet the vertical line, which is 2. And it's plus 20 over 2 because this line has a positive slope, and we know this because it increases from left to right. So the gradient of this line is plus 20 over 2, which is the same thing as plus 10. So the triangle method is as simple as this. Now I'm going to try some examples which will require that we place a negative sign in ratio of the vertical height and the horizontal length. You'll see this shortly. Here's another example. So here we have line PQ. Now because line PQ is such that it increases in height relative to the imaginary horizontal line here as you move from right to left, we know that this line must have a negative slope, i.e. its gradient must be a negative number. Now we know to determine the gradient of the line, so gradient of line PQ, you simply take the height of this vertical dotted line. So you have a line, you draw a dotted line downwards, then you draw a horizontal line from the lower point of the line to meet the horizontal line. And to meet the vertical line, the height of this vertical line you take and divide by the length of the horizontal line. And then you note the sign of your line based on its slope. You can see that this line slopes from right to this line increases in height from right to left relative to this horizontal line, so it has a negative slope. So I just place a negative value there. So the gradient of line PQ is minus 16 over 14, which is minus 4. It's as simple as that. So in summary, for the triangle method, given a line, you go to the top point, draw a vertical line downwards. You go to the lowest point, draw a horizontal line to meet the vertical line. Now, the height of the vertical dotted line you've drawn, i.e. from the top point up to the point where it meets the horizontal line, you know this line, now let's call it y. The length of the horizontal line from here to here, I'm going to call it x. Now, the gradient of this black line, so I'm going to call this line AB, is given by y over x, where y is the height, as described earlier, and x is this length. But you also need to note the sign of the gradient. You can see that this line increases in height relative to a horizontal line. I mean, if I draw arrows, you can see they increase from left to right. Therefore, this line has a positive slope. So I can put plus y over x, but I don't need to do that. But we have a line with a slope like this. Even if we had this construction here and this height was y and this was x, our gradient will be y over x. We have to place a negative sign there because this line increases in height from right to left. So it has a negative slope. And that's all for the triangle method. The key thing though is you would be drawing a line and drawing these vertical lines and this vertical line, this horizontal line. You literally be using a ruler to measure the length and the height. Unlike me, where in this case I'm just sketching. But it's the same principle. And the key idea is the gradient is y over x. Just make sure you note the sign. So I can tell you now in short that the gradient of a line is equal to plus or minus y over x, where y and x are just lengths or heights that you will have measured with a ruler. It's plus or minus because it's either going to be positive for a line with a positive slope like this line, or negative for a line with a negative slope like this line. So you have to decide by inspecting the line whether it has a positive or a negative slope. Next, we're going to look at determining the gradient of a line when given the coordinates of 2 points that lie on the line. So for example, consider this sketch of a graph. Imagine we have this line here, and you know that this point here has coordinates minus 3, 4. I'll call this point A, and I'll call this point B here, which has coordinates 1 and call this 1. Now, there's a formula to use. There's a formula which you can use to determine the gradient of a line when you're given the coordinates of 2 points that lie on the line. And the formula is as follows. The gradient of a line, m, so m is used to represent the gradient of a line. I don't know, it's not so straightforward why m will be used to represent something that starts with a g gradient, but that's the convention. It's given by the following formula. M is equal to y2 minus y1 over x2 minus x1. Or it's equal to y1 minus y2 over x1 minus x2. So what is x1? What's x2? What's y1? What's y2? Well, what you do is you pick one point on the line and let that point be x1, y1. So that's point 1 with x1 and y1. And you say let the second point be x2, y2. So in our case, x1, y1 is minus 3, 4. So minus 3 is x1, y1 is 4. Second point B. So x2 is 1, y2 is 1. So now using either this formula or this one, we can determine the gradient. Let's use the first formula. It tells us that m is y2 minus y1. In fact, let's list out our values. x1 is minus 3, so it's good practice. It is y1 is 4. x2 is 1, and y2 is 1. So m is y2 minus y1. y2 minus y1, 1 minus 4, divided by x2 minus x1, x2 minus x1, 1 minus 3. So it's x2, which is 1, minus x1, which is minus 3. So we have 1 minus 4, minus 3, divided by 1 minus 3. Minus times minus 3 is plus 3. So we have 1 plus 3, which gives minus 3 over 4 as the gradient of this line. Now the key, you could also have used this formula and you get the same result, and I'll quickly do so. But we're just going to stick to this equation as we proceed. So if I use that equation, we'll have m is equal to y1 minus y2, which is 4 minus 1, divided by x1 minus x2, which is minus 3 minus 1, And this gives 4 minus 1, 3 over minus 4. Same thing as minus 3 over 4. So we have the same result. So either formula is fine. I'm just going to stick to this. Now, one thing you should notice is that the gradient value we obtained is a negative number. It's minus 3 over 4. Why is it negative? Well, look at the line. This line, as you can see, relative to an imaginary horizontal line drawn in space, increases from left to right. And as you know, for such lines have negative slopes. Such lines have negative gradients. So when you have a line and you can see that it should have a negative line, you should ensure that when you determine the gradient using this formula, if you find that there's no negative line, then you know you've made a mistake. So let's try some other examples using the formula. So the key thing here to remember is when you're given 2 points on a line, you can determine the gradient of that line. And the formula to use is m is equal to y2 minus y1 over x2 minus x1. You need to remember this formula. It's not hard to remember. So imagine I tell you that you have a line, and the line is such that the point 4, 10 and the point 2, 5 lie on the line. What's the gradient of the line? Well, I'm just going to say, well, let this first point be x1, y1, and let the second point be x2 and y2. Therefore, from this, x1 is clearly 4 and y1 is 10. From this, x2 is clearly 2 and y2 is 5. Now I could have called this point x2, y2, and I've called this point x1, y1. It doesn't matter. You still get the same result. You can test it at home. Now I'm going to use the gradient formula. M is y2 minus y1. y2 minus y1, 5 minus 10. Divided by x2 minus x1, 2 minus 4. This gives minus 5 over 2 minus 4, minus 2, which is 5 over 2. And that's our gradient. That's all. So you can tell that this line actually has a positive slope. I'm going to try another example. Imagine you're given that the point 1, 0 and the point 8, 9 lie on a line, and you're asked to find the gradient of that line. You say, well, let this first point be x1, y1. Let the second point be x2, y2. So you know that x1 is 1, y1 is 0, x2 is 8, and y2 is 9. And using the formula, m is equal to, for the gradient of a line where you're given 2 points, y2 minus y1 over x2 minus x1, we know that the gradient of a line is y2 minus y1, 9 minus 0, divided by x2 minus x1, 8 minus 1. Which gives 9 over 8 minus 1, which is 7. 9 over 7 is our gradient. So this line also has a positive slope. It's that easy. Just use this formula and make sure you assign a point as this x1, y1 and the other point as x2, y2. Sometimes you'll be given 3 points which lie on a line and you'll be asked to find the gradient. All you have to do is just pick any of the 2 points and use them to find the gradient. So that's all you need to know.